and welcome back to another SAT math lesson. Today we'll be looking at the second module of the official SAT math practice test. This is gonna be a long video. I'll be showing the solutions to 27 problems. So please like this video, share it with a friend who needs it, and don't forget to subscribe. Without further ado, let's get started with the first problem. Tilly earns $P for every V hours of work, which expression represents the amount of money in dollars Tilly earns for 39 V hours of work. So, we know that V hours of work is equal to $P. So, what is 39 V hours of work equal to? Well, since V is equal to P, we can plug it in here and we'll get 39 $P. As you can see, the correct option is the option A. Now, looking at the second problem. For a training program, Juan rides his bike at an average rate of 5.7 minutes per mile. Which function M models the number of minutes it will take Juan to ride X miles at this rate? So, in this type of problems, you can think about a few values to get an understanding of the problem. So if for Juan to ride 1 mile it takes 5.7 minutes, how long will it take for him to run 2 miles? Well, we multiply 5.7 by 2 and we get 11.4 minutes. So how long does it take for Juan to ride X miles? Well, it takes 5.7 multiplied by X minutes. And the function that correctly displays this equation is in the option D. M of X equal to 5.7x. Alright. The solution to the given system of equations is x and y. What is the value of y? So we're given a system of linear equations and we have to solve it for y. So 3x is equal to 12 minus 3x plus y is equal to minus 6. In the second equation, we can move minus 3x to the other side and it will be positive. So we have y equal to minus 6 plus 3x. And since in this problem we know the value of 3x, we can use substitution to solve it. So y will equal to the value of 3x minus 6. So we have minus 6 plus 12, which is equal to 6. Now, sometimes you have to go the long way. You have to solve for x right here. So x is equal to 4. Then you plug it in right here and solve for it. But in this case, there is no need for that because we can use substitution and find the solution. So there we have it. Now, problem number 4. The equation gives the speed s in miles per hour of a certain car t seconds after it began to accelerate. What is the speed in miles per hour of the car 5 seconds after it began to accelerate? So we have an equality and we can think about it as a function because when we plug in a certain value of t, we get a certain value for s. So what is s 5 seconds after the car began the acceleration? Well, all we have to do is to put 5 in place of t in this equation. So we have 3 times 5, and that's equal to 40 plus 15, and that gives us 55. The correct option, the option D. Alright, now problem number 5. For the right triangle shown A equals 4, B equals 5, which expression represents the value of c. So a is equal to 4 and b is equal to 5. So for right triangles, there is a crucial formula we all need to know, and it's the Pythagorean formula. It says that a squared plus b squared is equal to c squared. Now we can take the square root of both sides. So let's do that. And if we do that, we get c equal to square root of a squared plus b squared. Now we know the values of a and b, and if we plug them in right here, we get c equal to square root of 4 squared plus 5 squared. That is the option D. Now, in the sixth problem, we're given an equation and we're asked what is the solution to the given equation. Well, we'll solve it just like any other equation. For x plus 5 equal to 165. We'll start by moving 5 to the other side. So we get 4x equal to 165 minus 5. That's 4x equal to 160. And let's divide both sides by 4. So we get x equal to 40. And that's the solution. The seventh problem, the x-intercept of the graph shown is x0. What is the value of x? So we have a graph and we have the function of some parabola, so it's a quadratic equation, and we need to find the value of x right here. I don't know if there is a more complicated and more detailed way to solve it, but I think the easiest way to go about solving this problem is to use symmetry. So this parabola is symmetric around this axis. And look at these points. These are also symmetric around this point. So to find the location of x, all we have to do is to find the value, the number between 6 and 8, and it's simple enough to do that. It must be 7. So 7 is the solution to this problem. Alright, moving on to the eighth problem. The function f is defined by f of x equal to 1 over 10x minus 2. What is the y-intercept of the graph of y equal to f of x in the xy plane? So this is our xy plane. This is the y-axis, this is the x-axis. And from the function we can see that f of x is some linear function that goes like this. And the y-intercept is the point where x is equal to 0. So for any function, we can plug in 0 here. So this becomes 0. So f of 0 is equal to minus 2. So that way we can find the y-intercept. And looking at the graph, when we talk about linear functions, the term right here after x is the y-intercept. So since we found f of 0, this is gonna be the y-coordinate, and we know that the x-coordinate is equal to 0, so writing the point is quite simple. So we just write 0 minus 2, and the correct option is the option B. Now let's look at the ninth problem. The function f is defined by f of x equal to 7x cubed. In the xy plane, the graph of y equal to g of x is the result of shifting the graph of y equals to f of x down 2 units. Which equation defines function g? Alright, again, let's draw the xy plane. And it's a 7x cubed, that's some cubic function. Let's draw something similar to it right here. And so this is the function f of x. Now g of x is the result of sliding this function down by 2 units. So this is g of x. We move all the points down by 2 points. And mathematically, this is equal to subtracting 2 from f of x. So g of x is equal to f of x minus 2. And if we plug in the function f of x, we get g of x equal to 7x cubed minus 2. And there we have it. The correct option is the option D. Looking at the 10th problem, which ordered pair xy is a solution to the given system of equations? So we have a linear system of equations, and again, it's not going to be too hard to solve this. We have x plus 7 equal to 10. We can solve for x right here, but instead, and then plug it in right below to solve for y. But instead, what we can do is that we can substitute the value of x plus y right here, because y is equal to x plus 7 squared. And what is x plus 7? It's equal to 10. So we get y equal to 10 squared. And let me write this more clearly. So we have 10 squared, and y is equal to 100. So x equal to 3, y equal to 100. The correct option must be the option A. Alright, next up, the 11th problem. Which expression is equivalent to 7x cubed plus 7x minus 6x cubed minus 3x? Alright, so for the first parentheses, we can write it normally. So we have 7x cubed plus 7x. But for the second parentheses, we need to multiply everything inside of it by minus 1. So the signs in front of it will change. So let's do that. We have 6x cubed, it becomes minus 6x cubed. And we have minus 3x, it's going to become plus 3x. So 7x cubed minus 6x cubed, that's equal to x cubed. And 7x plus 3x, that's equal to 10x. So the correct answer is x cubed plus 10x. Now let's look at the 12th problem. The function p is defined by p of n equal to 7n cubed. What is the value of n when p of n is equal to 56? Alright, so we have this function p of n is equal to 7n cubed, and what we have to do is to set this equal to 56 and solve for n, and that's what we're gonna do. 7n cubed is equal to 56, and let's solve for n. Divide both sides by 7. We get n cubed equal to 8. and we know that 8 is equal to 2 to the power of 3. So take the cubic root of both sides, or just common sense, because they must be the same thing. N will equal to 2. Alright, let's look at the 13th problem. In the figure shown, line C intersects parallel lines S and T. What is the value of x? Alright, intersecting lines this is very important to know for SAT, and the two most important things we need to know is that when there are two parallel lines and when these are crossing, this angle right here will equal to this angle. And we know that when we have a line, we have a straight line, the sum of the two angles that constitute it must be equal to 180. So let's solve the problem. Since this angle right here is equal to x, this angle right here must also equal to x. And the sum of these two angles, 110 and x, must equal to 180. Let's set up the equation. 110 plus x is equal to 180. These are all degrees, by the way. So x is equal to 180 minus 110. And we get x equal to 70 degrees. So there we have it. The correct answer is 70 degrees. Now, in the problem number 14, we have a list of 10 data values. What is the mean of these data? Alright, so when we're solving for the mean, we have to add these all up and divide it by the number of elements, number of data values. So we know that we have 10 of them. You can count them again if you'd like. So let's just add them all up. 6 plus 8 plus 16 plus 4 plus 17 plus 26 plus 8 plus 5 plus 5 plus 5 divided by 10. So I'll just plug them in my calculator and get back to you right when I solve them.